Shadowing. The shadowing term notes a zero-mean Gaussian random variable with standard deviation sigma, which is estimated from the experimental data. The shadowing term captures the path loss deviations from its median value. Figure 9 presents a comparison of empirical cumulative distribution functions, CDF, of the estimated shadowing terms and theoretical log normal CDFs with respective standard deviations for different bandwidths, shown in Table 3. For comparison, a far-right column showing the calculated parameter values in free space at central frequency of 6.85 GHz, 7, is added. In a 3.6 GHz to 6 GHz indoor loss measurements, Cassioli and Durantini, 2004, shadowing is modeled as log normal, with standard deviation of 1.42 dB for indoor loss scenarios. Empirical CDF of the shadowing terms obtained from the experimental path loss values for different bandwidths. The black line on each CDF represents the theoretical log normal CDF with the respective calculated standard deviation. Measured path loss at a reference distance d equals 0.1 meters, path loss exponents non-standard deviations of the shadowing terms for different bandwidths. Note that the standard deviation of the shadowing terms decreases as the bandwidth increases. An UWB indoor loss channel measurement campaign was evaluated in Cassioli et al., 2001, finding standard deviation of shadowing term of 5.9 dB. An extensive research based on analysis of over 300,000 power delay profiles measured in 4.375 GHz to 5.625 GHz for indoor loss scenarios presented in Basemzadeh et al., 2002, reports on the standard deviation of the shadowing term of 1.6 dB. Mean excess delay. Mean excess delay is commonly used to describe the time dispersion characteristics of a transmission channel. It is defined as the first moment of the power delay profile. The scatter plot of the mean excess delay values, estimated according to 13, from the measured power delay profiles, is presented on Figure 10 in dependence on the antenna separation for different bandwidths. Figure 11 presents a scatter plot of the estimated mean excess delay in function of the estimated total path loss for different bandwidths. We find a significant correlation between these two parameters, which is slightly increasing with the bandwidth. Scatter plot of estimated mean excess delay versus antenna separation for different bandwidths. Note that the correlation between these two estimated parameters increases with bandwidth. Scatter plot of estimated mean excess delay versus estimated total path loss for different bandwidths. Note the slight increase in correlation for larger bandwidths.